Chapter 7, EE160, about structures. And my examples are hurricane themed. That's why there's a hurricane on this first slide. So structures. A structure keyword lets you define a collection of variables of different types, so they could be ints, characters, arrays, and group the whole thing together and call it a structure, and you can treat the structure then as a single unit. So it allows us, remember, like an array is only one data type, but this allows you to have a chunk of data of different types all grouped together with the same name. So it defines a set of data, and not all the data types have to be the same. And it's supposed to say right down there that this kind of a structure is a thing that aggregates data types. So that should say types right there. Okay, so example. First, let's show you how to define a structure. In my example, my structure is going to be a hurricane. So I define it struct with the keyword struct, and I give it a name, hurricane. And that's called the structure tag or the tag name. And so hurricane right now is a new data type. So like an int is a data type or a character is a data type. Hurricane is now a data type that we can use in our programs. We have it available to us, but we'll still have to declare it when we're ready to use it. So I've declared this structure called hurricane, and these are the members of the structure down here. So the data type hurricane has a member called name, which is a character array. It has a member called year, which is an integer, and it has a member name called category. So these are members of the structure. In object-oriented programming, they would be properties, which you can learn in the sequel to this class. So anyway, these are the data members of this data type that's called hurricane. So after you define the data type, hurricane, now you can declare it in your program and initialize it. So I'm going to declare a variable called h1. It is a data type hurricane, which is a structure. And then I'm going to initialize it with the values right here of Camille, which you can guess is its name, and its year, and its category, which is in the same order as the things that are when we define the structure. We have name, year, and category. So now when I declare it in my program, just like we do any other declarations in our program, I can initialize it with values for the members of it. I can also use now these members. For example, I can say printf name is, and I can say h2 dot, oops, this should say h2. That should say h2. So h2 dot name. Ooh, that's a picture too. I can't change it. So h2 dot name would output Camille, h2 dot year would output 1969, and h2 dot category will output a 5. So your textbook on page 336 talks about you can also, instead of initializing my variable called h2, here I have it called h2, you can just declare a variable h2 just like you can declare an int but not initialize it, and then I can go and assign values to it. So your textbook says I can say h2.name equals Hugo, h2.year equals, h2.category equals. I'm going to tell you right now that the first line does not work. The correct way to do it is my example down below. So h2.year is fine and h2.category is fine because they are integer data types, but a name is an array. It has an address. So the only way I know how to do it anyway is with this string copy command, which means I have to have string.h in the preprocessor declarations, correct? But anyway, this one does work. I ran the program. So if I do a string copy h2.name and put Hugo in it, then this definitely works. So how do we input and output to structures? I'm going to do the example on page 337 in your textbook, which is an example of doing input and output. So here's the program right here. I'll start it from the beginning. So this program is going to read information for hurricane from a data file and then print it. And the program is going to create a structure called hurricane, just like we showed a moment ago. But it's going to take the data from the file and fill it into structures. Well, you'll see what will happen in a moment. Read it in. So let me show you what the data file looks like first, because that's always informative. I think I'll open it right there. So this is what the data file looks like. There's a list of hurricane names, their year, and their category. I was a little disturbed by this extra space in here. It shows this way both in Notepad and Notepad++. But that's what the data file looks like that the program has to read into and put it in a structure. So we do the normal defining a file name so that we can work with files. Here, this part of the program declares the structure called hurricane, and notice that it is before the main of the program. You can actually declare them within the main also, but this makes it more global if you declare it outside of main. So other parts of the program can use it, like functions, for example. Okay, so now we have a data type called hurricane available to us, but we have to declare a hurricane of type data, of type hurricane. We have to declare a variable of type hurricane, and I'm going to call it H1. So next part of the program just opens the file name storms for reading it, provided that we've opened it correctly. Each line of the storms file gets read in from an fscanf function, from a file scan function. Little bit of a trick here. So normally you would read in an integer and save it into some address specified by this address operator, address of H1, for example. But note what's different here. You store the second column of data in H1.year. So it's the declared structure. The member is year. So it stores in H1.year. The category stores in H1.category. But the trick here is look at H1.name. So it does not have that ampersand in front of it because name is an array, and so this is a pointer to the array called name at this point. So anyway, so it reads in the file and then it's going to print it out to the console. So the hurricane is h1.name. It reads out. The year is h1.year. And the category is h1.category, and it will read out the values that it's reading from the file to the console, and then close storms. So I ran it already, compiled it and ran it, and so this is what it outputs, just as expected. So it read everything from the file and read it out to the console for us to see. Didn't seem to have any trouble with the extra spaces in it, so that was nice to see as well. There we go. Not quite fitting in there, right, was I? Okay, so it read it out all just fine. Good example of using a structure for the hurricane. So operations with structures. You can assign one structure to another. For example, I can have hurricane H2 equal H1. I should have a declaration statement for it first, but and then everything that's in H1 will get assigned to H2. You cannot compare structures with rational operators. For example, you cannot check to see if structure H1 is the same as structure H2. However, you can compare members of the structures. So I can say, for example, if H2.year is identically equal to h1.year, then do something. That's okay. You can also use entire structures sorry, here's another table. You can also use entire structures in functions. So you can pass an entire structure as an argument to a function. And so let me give you an example of that one. This is example 7.3 in your textbook. So it's similar to the first example that we just did. We declare a structure called hurricane. The members are name, year, and category, with name being an array of characters. And then I go into the main of my program. I declare my hurricane, H1, and then I have some declare pointer to a file. And here is a function declaration right here. Doesn't return anything, but it's print hurricane, and it is expecting an argument of type structure, structure hurricane actually, and there's the variable, the argument that the function is using. So let's go down and look at that function for a moment. Here is the function to which we are passing a structure hurricane data type to it. So it's expecting a structure hurricane, and there's where the name of the hurricane that you'll pass to it, like H1 for example. And so instead of saying H1 here, this is within a function, so I'm printing printf h.name, h.year, and h.category. But I've passed to this function is expecting to be passed an entire structure. So when I call this function, I will call the function print hurricane, and I will pass to it H1, for example. So let's go back and look up at the top of the program. So now I open the file for reading, and then I fscanf all of the values and then print them to the screen. So here's the same fscanf statement. So h1.name, h1.year, and h1.category get these three values from each line of the file as we're reading it. But then I just call a function, print hurricane, and what do I pass to the function? I pass a structure hurricane to it. It's named H1. So I've called the function right here. I've passed to the function a structure, a hurricane structure really, and its name is H1. And so I call the function and I pass to it the structure, hurricane structure H1, and then the function does its thing. And there's the function. So you can pass an entire structure to a function. So okay, I think we'll stop there. It's a pretty big chunk of new information for you to assimilate. I would very much recommend that at the end of the chapter, where there are multiple choice problems, page 368, I would actually quite suggest that you review these multiple choice problems. So the answers are in the back of the book, so check yourself. Page 368, problems number 6, 7, we don't want the pointer one yet, 6, 7, and 8. 6, 7, and 8. Make sure that you review those. Those are like, you know, good final exam test questions. So review these. Problems at the back of your chapter relevant to this material that we've been covering today. Two big important concepts, structures and dynamic memory allocation have been covered this week, and I think that's sufficient for you to do some homework with it. Okay, bye now.